So we've got some inequalities here. Hopefully, so the stuff in the red and the blue on my screen, you've seen before. So when we have a or equal to, like greater than or equal to, or less than or equal to, we have a closed circle. When it's less than or greater than, we have an open circle. And then we draw an arrow, depending on the way that makes sense, based on the problem. What we have today is the ones in the green. So either and inequalities or inequalities. So it's and if they overlap. So if you look at this here, you've got, so here are the two inequalities. They overlap from 3 to 7. And so the compound inequality would be x values greater than 3 and less than 7. Or sorry, greater than or equal to 3 and less than or equal to 7. Correct myself. Over here, do these ones overlap? No. So or inequalities do not overlap. They end up basically just being like, take those same two things and graph them just on the same line. That's basically all you do. And you say or. So if you see this word or, you're going to have them kind of separate on the number line. If you see and, they should be overlapping. Now, sometimes we don't see and. So if you look at this paragraph here, we won't read the whole thing, but you can write x is greater than or equal to 3 and x is less than or equal to 7 as this right here. So we can write it like in one inequality by saying, putting x in the middle and saying it's greater than or equal to 3, it's less than or equal to 7. So to read this part on the left, you have to kind of read from right to left. But basically think about it like x is between these two numbers, and it does include 3 and 7 because it's got those or equal to's. Another way to read it, so x is greater than or equal to 3 and less than or equal to 7. We can say x is between 3 and 7 inclusive. What that means is that it could be equal to 3 and it could be equal to 7. If you look over there by Carly, we've got those includes, excludes. If it says or equal to, or if we say it's inclusive, we're saying it includes those numbers. And so it's going to be a closed circle. If it's exclusive, it does not include and be open. Okay, so we solve the same way pretty much. We'll get to that in a second. Right now we're going to write. So it says all real numbers that are greater than -6 and less than 2. When we see all real numbers, it's just talking about like your x values. So instead of putting like all real numbers, we're just going to put x. So numbers that are greater than -6 and less than or equal to 2. What should I do? Okay. X has to be greater than 6, right? And less than or equal to 2. Let's do one at a time. If I want x to be greater than 6, then the bigger part of the inequality has to be facing the x. X is greater than -6. Because it's between these two. And then less than or equal to 2, so that would be a regular less than or equal to. The smaller side facing towards the x. So that says that all in one thing. We were able to write it like this because it said and. Because it said and, we can write it all in one like that, like in 3 parts. X is between -6 and 2. That's what we're saying. So we're going to graph it now. I don't think I left enough space on the graph to go by 1s, so we're going to go by 2s. And if I had to redo this, I would not make these dashed lines, but too late now. So here we go. So it goes, we'll say -6, -4, -2, 0, 2, 4, 6. So we're going by 2s, so it fits. X values greater than -6. So ignore the 2. If x values are greater than -6, will it be an open circle or a closed circle? Open. It does not include -6. And then x values less than or equal to 2, open or closed? Okay? And look at your little sentence there. It's just saying the x values in between that. So what you do is draw this like, kind of like a dumbbell. It's saying the values in between those. So anything between -6 and 2, and also it includes 2. I think this is kind of fun. The good news is most of the time, this is just going to be a 1 or 2 step equation, which y'all know how to do. So we're going to draw a balancing line, but instead of drawing one balancing line, we're going to draw 2 balancing lines because we have 2 inequalities. And so what I do to the middle, I must also do to the left and to the right. How fun. Right? Okay, this isn't bad, y'all. We're just trying to get x by itself in the middle. It's not bad. X is adding 3, so how do I take away the 3? Subtract the 3. Everywhere. In the middle. On the left. And on the right. We subtract 3, and then we get -8, because -5 down 3 more is less than or equal to x is less than 3. So done. That's it. So now we're going to graph it. So I made a mistake here. I shouldn't have made those dashed lines, so this isn't going to make much sense, but we're just going to label -8 and 3 and call it a day. So we're going to say -8 is here, 3 is over there. It includes -8 because it says x is greater than or equal to -8. So that's closed. And x is less than 3, so that is open. And it's the x value is in between, so you draw a line between them. Because this is an and inequality. Again, we talked about if this is and, which it is, ones like this are and inequalities, then they're going to be overlapping like that. Cool. Let's do another one. This one's 2-step, but you guys know how to solve 2-step equations. So we're going to draw our balancing lines. What I do to the middle, I must do to both sides. I've got 5 is being added, and then a -1 is being multiplied. So Carly, what should I do first? I'm trying to get p by itself. Subtract what? 5. So subtract 5 from the middle, from the left, from the right.
I got it.
So that would be 2 is less than -1p is less than or equal to 7. And Maddie, what do I do next?
Divide by -1.
Why am I dividing by -1?
Because the p is negative and you undo negative.
Okay, we're undoing multiplication. Divide by -1. Everywhere. Which will make the middle part, that'll make it go away. Cancel out there. Ariana?
Would you flip your sign?
You do. So just like you would normally, flip the signs. So p is now less than -2 is greater than -7. This is going to be confusing to graph. So what we should do is flip the entire, like rewrite the entire thing, just like we did on Monday when I asked you to rewrite. So we're going to put -7. So we'll put like a mirror, and we're going to flip the whole thing. So it'd be -7 is, we want them to face this way, remember? That's how it makes sense, less than or equal to. Thank you. P is less than -2. So we just flip the entire thing. We want the smallest numbers to be to the left. We want P to be in the middle. We want the greater number to be to the right. And we want the inequality signs. We want the alligator to be eating towards the right. Let's make our little graph. -7, -6, -5, -4, -3, -2, -1. Will it be open or closed at -7? Closed, because it's or equal to. And will it be open or closed at -2? And its p-values between there. So you draw like a dumbbell. So we're going to solve these two separately and then graph them on the same line. So we're going to draw the balancing line. And Ava, what should I do first to solve that inequality? Because it's being subtracted. So that would give me 22 is less than negative x, so negative 1x. Ryan, what next?
You divide each side by negative 1x, or negative 1.
And what happens when I divide by a negative 1?
The sign switches.
Right. So negative 22 is now greater than x. Remember, that's kind of difficult to graph. So if you see something like this, we want to get the variable on the left. That way it's easier to graph. So I would flip this entire thing like a mirror image and rewrite it as x is less than negative 22. It's the same thing. All right. It's an OR inequality, which is why they're separate. So they are going to be graphed separately on the same graph. So let's do the next one. Maddie, what first? So we get 2x is greater than or equal to 6. Zach, what next? So x is greater than or equal to 3. So we have our two inequalities. You would graph them like you normally would, just on the same graph. So we're going to label negative 22 and we're going to label 3. We're going to leave them separate because they're OR. So I'll put negative 22 over here and I'll put 3 over here. Open. Less than would go which way?
To the left.
Smaller numbers this way, and then closed at 3 and greater is to the right. Check it. If you have an OR inequality, they should not overlap. If they overlap, then something happened. So what we're going to do is use averaging. Remember, when we average, we add them all up and divide by how many there are. So we can go ahead and do that. So 85 plus 86 plus 80 plus my fourth test, which I could say x. If we're going to use x, we should say what it is. Let x be equal to the fourth test. How many tests do we have? Total. 4. So we're going to divide by 4. And our test average, we want our test average to be between 84 and 86. So 84 would go over here because it's a smaller number. And 86 will go to the right. We want our score to be, for sure, greater than 84. Can our score be equal to 84?
Nope.
Yes, because it says inclusive. 84 and 86 inclusive, which means it could be equal to 84. So it's going to be less than or equal to 86. Anybody on their calculator want to tell me? Is it 251? Okay. We trust you. 251 plus x divided by 4.
62.
And then everything else stays the same. We don't need to move our variables because there's only one that's in the middle. So what we're going to do next is solve it out. Remember when we have a two-step equation like this, it's like we have parentheses on the top, so you can't get rid of the 251 first. You have to get rid of the 4. So Luke, how do I get rid of the 4?
How do you get rid of the 4? Oh, crap. You multiply it.
Right, so we're going to multiply by 4 in the middle, on the right, and on the left. So that'll cancel out the 4 in the middle. Someone do some math for me. We believe you. 336 is less than or equal to 251 plus x is less than or equal to, what is it? 24? What's my last step? Can someone raise your hand and tell me my last step? Luke?
You would subtract 251 on both sides.
Right. So subtract 251 because it's positive. So that's addition. I believe we get, is it 85?
Sure.
You can check my math. I'm doing it in my head.
I would, but I'll trust you.
And 93 when you subtract those. So that's your inequality answer. It's a word problem. What do you think we should probably do? Write a sentence. So you need to score between 85% and 93%.
This is